All right, this is for Algebra 2 from a little bit from 7A, mainly 7B. And we are starting the imaginary numbers. So these first two are from 7A and everything else is going to come from 7B. But remember, I want you to show your work on here. If this is not a perfect square, find a perfect square that will go in there. For example, 4 will go into there. So I'm going to write that as -4 times 3, because 4 times 3 is 12. Okay, why did I not use 6 and 2? Because neither one of those would be a perfect square. And I want to try to find a perfect square that will go into 12. All right, and then this is, let's see, I think 81 will go in there twice. 81 times 2 is 162. So I think it's easiest if you kind of circle the part that is perfect. So remember, this is 3 times the square root. Well, when you pull him out, he becomes a 2i. So you have a 2i times 3, and then this guy has to stay under the radical because he's not perfect. Plus, okay, this comes out, he becomes a 9i times 4, and then under the square root of 2. So right here I have 2 times 3, so I have 6i square roots of 3 plus 36i square roots of 2. You cannot add these together because they are not like terms. In order for you to add them, they would have to be exactly the same under the radical. So that would be your answer there. Okay, so let's try another one. And remember, I said in class, if this is an even exponent, it's a perfect square. So if, for example, if I had the square root of x to the 10th, it would be x to the 5th. Because x to the 5th times x to the 5th is x to the 10th. That's why. Okay, so one more, the square root of x to the 18th would be x to the 9th. Okay, I know that's really weird. So this guy is already perfect. Love that. Does 20 have a perfect square in it? And I would say, yeah, 4. 4 times 5 is 20. And I personally like to circle what I can pull out. And that way I know what still has to stay under the radical. So when you pull him out, think about it. That's a 2i. When you pull this out, it's an x, and I'm still left with the square root of 5. Now, you could leave it like that, but typically you're going to see the I written on the back end, so you would see it as 2xi square roots of 5. So that should be my answer right there. I'm not going to get real picky with that, but your I does usually go on the end. Okay, this is from 7b, and is there a perfect square in 45? And I would say yes, 9. So 9 times 5 is 45. I'm just kind of leaving my negative sitting right there. This is odd, so it's not perfect. And I didn't do one like this in class. I forgot. But I tell you what, the easiest thing to do is lower it by 1 and then leave your remaining x there. Because x to the 8th times x to the 1st is x to the 9th. Because remember, if this is an even exponent, he's perfect. So this is a perfect square. And then I can also pull this out. So think about it. When I pull out my 9, it's a 3. So I'm taking care of that one. When I pull out my x to the 8th, it's x to the 4th. So I'm taking care of that one. If I pull my negative out, it's an I. And then underneath my radical sign, I have a 5 and an x. So that would be my answer right there. Crazy. All right, so that was 7b. Let's try this one. Perfect square in 200 is 100. That's already perfect. So realize the square root of 25 is 5. So I've got that right there. So that one's kind of weird. This guy will come out. Remember, when he comes out, he's a 10i. So I have 10i times 6. And then that's times the square root of 2 minus 25. So final answer, I can multiply, they're on the outside of the radical, so I can multiply them together. So I have 60i square root of 2 minus 25. And that would be number 9. Okay, even exponent, he's perfect. So if I take the square root of x to the 4th, it's x squared, but there's a negative under there, so I can pull that out and make it an I. This is perfect, this is perfect, this is perfect because they have even exponents. The square root of 16 is 4. The square root of x to the 4th is x to the 2nd. And the square root of I squared is just I. Notice these are like terms. I have 1 x squared I plus 4x squared I, which is 5x squared I. Okay, what about this one? Ooh, I think that's a perfect square, and I had to squish in my little negative. I about forgot it. So I have 6. That would give me, what, a 13i, because the square root of 169 is 13, times 2 times 9i. Okay, remember the square root of 81 is 9. When you pull out the negative, it's an I. So use your calculator and hit what is 6 times 13 times 2 times 9. So crunch that in. I'm like, what is that? This is number, what, 20? I'm going to peek because I don't know that mentally. So I'm going to get 1,404, and I times I is I squared. What's I squared? Remember, that's negative 1. Negative 1 times 1,404 is negative 1,404. So that should be your answer on that one. Okay, remember we talked about this in class. This is by definition. Probably should have covered this at the top, at the very beginning, but don't forget, I'm stuttering here, that I is defined to be the square root of negative 1. So I squared is going to be negative 1. I to the third is negative I, and I to the fourth is 1. These 4 you need to memorize and you need to know. But honestly, if you know 1, you could do them all. But those are great because on your test, I'm going to ask you something like I to the 18th. And you're going to have to be able to figure that out. And remember in class I told you the easiest way to do this is in terms of I to the fourth. Figure out how, because that's 1 and I love him. So you're going to figure out how many times will he go in there. And I would say 4 times because that gives me 16 with 2 left over. So this is 1 right here, and 1 to the fourth is still 1. So all I have left is I squared, and we all know that I squared is negative 1. So that's how you would do that. Enjoy.